Today we'll discuss our project on the customer churn prediction using machine learning. Customer churn occurs when the customers stop doing business with a company, which is especially common in the sectors like telecommunication, e-commerce, and subscription-based services. When customers leave, it's not just a loss of revenue, it also increases operational costs. It is much more expensive, up to 5 times, to acquire new customers than to keep the existing ones. Additionally, high rate of customer churn can negatively affect the company's reputation, making it harder to attract new customers who might be wary of joining the services where many are leaving. To address these issues, our project aims to develop a machine learning and the model capable of prediction when customers are likely to churn. By accurately predicting the churn, companies can implement proactive strategies to retain customers, which could include the personalized offers and improved service features. And the expected outcomes of this project are to increase the accuracy of churn predictions, provide valuable insights that can inform the business strategies, and help optimize the allocation of the resources by focusing efforts on customers who are at risk of leaving. This approach not only aims to reduce the churn rates but also enhances overall customer satisfaction and loyalty. Previous research in customer churn prediction has extensively explored various industries with a strong focus on the sectors like telecommunication, finance, where maintaining customer loyalty is crucial. These studies commonly use machine learning techniques, including the decision trees, logistic regression, and neural works, to analyze when and why customers are likely to leave. Findings from the studies emphasize importance of the personalized customers interactions and deep understanding of how customers use services to effectively reduce churn. However, researchers have encountered significant challenges, such as handling databases where the number of customers who leave is much smaller than the customers who are holding it. Instructions are deep understanding of how customers use services to effectively run churn. To overcome these issues, part research suggestions improving the quality of the data used and incorporating the broader range of data sources. Moreover, adopting more sophisticated machine learning techniques could potentially lead to better predictions of customer churn, allowing companies to take timely actions to retain their customers. The goal of this project is to create computer program that can accurately predict when the customers are likely to stop using a company's services. By doing so, the company can take steps in advance to keep the customers. This project will use a well-known dataset called Tele-Customer Churn Dataset, which has detailed information about the customers such as their personalized demographics and how they use the services. The approach includes exploring the data and understand the patterns, creating a new data features that might help in the prediction and experimenting with various machine learning techniques, including random forest and gradient boosting, to find the most effective one. The expected benefit of this project is to decrease the number of customers leaving by spotting them early and addressing their concerns, thereby increasing overall customer satisfaction. The project aims to be completed with a semester using tools like Python programming language and scikit-learn library, which are the standard for such data science tasks. The project uses a dataset called Telecustomer Churn Dataset available on Kaggle, which includes records of 7,043 customers. Each record has 21 different pieces of information or features about the customers. To prepare this dataset for analysis, we first handle any missing values, particularly in the total charges field, by filling them in with the median value of the field. This helps maintain the quality of our dataset. Next, since some of the dataset is categorical, meaning it represented by the labels rather than the numbers, we convert these labels into a numeric format. This conversion, known as a one-hot encoding, allows our machine learning algorithm to process the data more effectively. We also scale the numerical features to ensure that all the data points are similar scale. This prevents any single feature from having too much influence over a predictive model due to its range of values. In this part of project, we look closely at the data to uncover the patterns and insights before building our predictive model. We start by figuring out how many customers have left company versus those who have stayed. This gives us a clear picture of overall churn rate. Then we dig deeper into the data to see if the certain characteristics like customer age, gender, or other type of services they use affect the likelihood to churn. For example, if we check customers with a certain internet or security services are living at a higher rates. The violin plots This set of plots can visually summarize how tenure charges relate to the churn, providing insights to customer loyalty and pricing sensitivity. We also use statistical tools to see which feature of the data are most connected to churn. A heat map can help us to see the relationships clearly, showing which aspects of the service or the customer's profile are good indicators of potential churn. Throughout this analysis, we use various graphical representations like histograms, which show us how frequently the specific value occurs, and a violin plots, which are combined box plots, density of plots to show the distribution of data that make it easier to spot trends and unusual patterns. These visuals are crucial as they make complex data more understandable and helps us to identify where we might focus our efforts to prevent customers from leaving. In this part of the project, focusing on selecting most important features or pieces of information from our dataset significantly affect whether a customer will leave the company. This process, known as the feature selection, helps us to build a better predictive model by only including the variables that truly matter. For this, we use a technique like recursive feature elimination and examine which features are considered most important by the model, such as random forest. We found that the features like how much a customer pays each month, that means the monthly charges, how long they have been with the company, tenure, the type of contract they have contacted, and the total amount of the paid over time are the critical in the predicting churn. By focusing on these key features, we ensure our model isn't distracted by the less important information which can lead to the overfitting. When a model is too closely fitted to a limited set of data points and performs on poorly on the any new data. Additionally, using fewer but more impactful features make our model faster to train, which saves time and computational resources. It makes our model simpler to understand and explain, which is important when making business decisions based on models prediction. This approach not only makes a model more accurate but also more efficient and user friendly. This bar chart illustrates the relative importance of different features in the predicting customers' churn as determined by the random forest model. Features like a monthly charges and contract appear to have the greatest importance, suggesting there are any strong indicators of whether a customer might leave. High monthly charges could indicate the cost of significant factors of customers, and the nature of the contract could influence their decision to stay or switch the services. Other features like total charges and tenure monthly charges interaction reveal both of a long-term value and the relationship between how long a customer has been with the service and the monthly charges are influential in predicting churn. The results in this image show us a report for four different computer programs that were tested to see how well they can predict the customer churn will stop using the company's services. These programs are built using a different machine learning models. We check how well they do by looking at few things: how many predictions they get right, how many customers they correctly identify as leaving, how good they are catching the most of the customers who do leave, and an overall score balances the precision. There's also a score called ROC code that tells us how confidently the model can tell the difference between those who will leave and those who will stay. Hyperparameter tuning is like a fine tuning a musical instrument to get the best sound. For machine learning models, it means adjusting the settings that control how the model learns. We want to make these adjustments to make our predictions as accurate as possible. To do this, we used a tool called Grid Search CV, which tries out lots of different settings to find the best ones. For a best model random forest, we looked at the settings such as how many trees it should use and how detailed each tree should be. By changing these settings, the model got better at predicting who would leave and who would stay without making too many mistakes. This process is like a bit trial method. Each model is scored based on different few things. Many times its accuracy, how often it currently identifies the customers who are about to leave, how good is finding all the customers who will leave. A score that balances the precision and recall, F1 score, and how well it separates those who will leave from the who won't. Two models called Random Forest and SPM were given a bit of extra fine tuning, like adjusting an instrument to get the best sound, and then their scores were recorded again. It turned out that the random forest was the best model, both before and after extra tuning. It scored high across the different ways we were measuring, which means it's a reliable tool for the predicting customers' behavior. This is really useful because it helps the company to decide the best ways to keep their customers happy and prevent them from leaving. In conclusion, our investigation shown that the best way to guess if a customer might stop using a company service is to use a random forest model. It got the highest scores for its prediction by making some adjustments to this model, and other one called SPM. We were able to make them even better by guessing correctly. These findings are very valuable because they help the business to figure out which ways to keep their customers from leaving. Looking ahead, we suggest that the companies would try even more advanced method to use set up up-to-date minute information to predict customers' behavior even better. Lastly, this project really showed how important it is for the companies to look at data and use what they learn from its mistake. Smart choices, especially when they want to keep the customers happy. For the next step in this work, we're thinking about how to improving the ability to predict if a customer leave a service. One idea is to use new up-to-date information as it comes in. So our predictions are really based on the latest data. We also want to try using more complex types of computers like known as deep learning and neural networks, which might be even better at making predictions. Another thing we'll look at is whether we can learn more by considering different kinds of information like how customers interact with the company's service team or what they say about the company on the social media. We also want to make sure to understand why our computer program makes the decision it does, which can help us trust and explain the predictions better. Finally, we are planning to put this program to work and the real watch how does it over time, which will help us to making it better. So that's all it's about the project. As a wrap up, I want to give a big thank you to everyone who have worked together to make this project a success. It's really important for a business to understand and predict when a customer might stop using the services, and that's what we focused on here. It's amazing to see how machine learning and analyzing lots of data can help solve real world problems that companies face. I also want to encourage everyone to keep researching and learning in this area because the way customers act can change and we need to keep up with those changes. Lastly, I appreciate all of you for listening and joining in this journey through the presentation. Your attention and interest mean a lot, and I hope you found it is exciting and valuable as I did. Thank you.